guys, another example I'm going to demonstrate for you from chapter 4. This example is about descriptive statistics and question number 8. Let's open it in data. There are 3 different variables. Let's open it in StatCrunch. My preference, but you might, again, easily do this in Excel. You want stat, summary stats, columns. You want all 3 columns. I think they ask you questions about all 3 of them. So Control A. You might as well get, I'm not sure what you're going to need here. So let's do all of them, compute, and we have 3 sets of statistics. The number of data values is 15. That's easy. Get rid of this. 15. Correct. It's a mean of the house age. House age is here. House age mean is 29.13. Copy. Paste. Enter for testing it. Correct. Compute a deviation from the mean for the first house age of 27. So let's go. The first number is 27. The deviation is how far from the mean. So it's basically 27 minus the mean. So 27 minus 29.13 is minus 2.13. You can do that on the calculator. Minus 2.13. Again, it's the mean minus that's the score minus the mean. Now we did that. Compute the variance of the house age data. Well, that's just done for us. The variance is 5.26. C. Control V. Enter. No. Variance of the house age data is. Okay, here's again. I just got caught by a very subtle mistake. I made this mistake before. We're talking about, usually we have samples. It looks like a sample, but they're claiming this is the entire population on the street. So it's the whole population. So when you're dealing with a sample, the formula, which is used 99% of the time, has an n-1 on the bottom. But the formula for the population has an n. So it changes it. But that's also available to you in MyLab and StatCrunch. It's called the unadjusted variance. It's called the unadjusted variance, so it's 4.91. I bet that's right. Control C. Control V. Oh, wow. Okay. Compute the standard deviation of the house age data. So again, you have to use the unadjusted one. It's 2.21. Control C. Control V, and enter. We're on a roll. Compute the mean of the square feet data. That's another measure of the house. Square feet would be probably the second one. And the mean is this thing here. I don't want to repeat this. Deviation 1668 is the score minus the mean. So how much is 1668 minus 157.4? Well, probably do that in my head, but I'll show off. So it's going to be 1657.4 minus what? Oh, sorry, it's the opposite. 1660 is the score, the x minus the x bar minus the average. 1668 minus 1657.4. That's positive 10.6. deviation. Okay, don't make us repeat it another time. Compute the population variance. All right, fine. Tedious, but we'll do it. The variance is this number here. They want everything to at least 2 decimal places. Copy. Control V. Oh, I made the same mistake again. All right, I went to the. Look at that. Yeah, but I'm human. You want to go to the unadjusted variance, which is 192.50. C. That. Control V. That has to work. Final now. If they repeat this, okay. Now we want to do it for the unadjusted standard deviation, which is right here. Oh, 222.76. Control C. Control B. We're on a roll. Computing. Oh, well, now I can do it a third time. Is that really worthwhile doing? Is there any educational benefit from that? All right, this time the average is, well, C. That's the deviation from the mean. Okay, so it's 90,000 is the number minus the mean. So it's 90,000 minus 88,193. So 90,000 minus 88,193.33. So it's 1806.67. 1806.67. 1806.67. No, really wrong. 1806.67. Computing from 90. So 90,000. Start it again. 90,000 minus 88,193.33 equals 1806.67. 1806.67. I don't know what I'm doing wrong here. We'll find out. Check answer again. Let's try it again. What? I think the book has a mistake here. Let's check. Let's look at this somewhere. 90,000 minus 88,000. Oh, I'm so stupid. You see? You see? Not reading. Okay. I wrote it as 90,000, but it's 90,900, as some of you who are watching at home might have realized. So it's 900 more than I said. Okay. Population variance, we got to go back to that again. The unadjusted one. For the market value. Large number. Control C. The market value is 99. Maybe it's too late at night. 99. Let's see what's going on here. Adjusted variance for market value. $9973.7956. 9373. I don't know what's going on. Maybe there's some decimal places here that I'm not seeing. Oh, you know what? I do remember this mistake. They rounded to the nearest whole number because it's such a big number. But it's really, this number with the decimals the right answer. Yes, I came across this mistake once before. It's really totally unfair, but I'm glad you're hearing this, how to solve it. You take that number, Remember, the variance is the square of the standard deviation. So you take 9681.8364, square it, and you get 9373,956.07. We left out a 0.07, and that's why it was marked wrong, I think. We'll find out. 0.07. Okay, let's see if that's right. No, let's see how far over I am. Check, final check. 955. Nope, my number says 956.07. 9973795.6. You know what? I'm not sure how they're getting their number. 955.56. They rounded it to. Okay, let's try that again. Back here. So this number here, 99. Let's see, maybe I wrote something wrong. The square root of it. 9681.8364. That's right, that's the number. Squared is 956. I don't know what I don't can't explain this. Okay, I'll write to the publisher and find out what's happening, guys. I'm sorry about that. All right, the standard deviation. We just did that. That number was 9681.83. 9681.83. That's okay. So this got to be the square of that. That's it. We're done. So this was a careless mistake, and this I don't know why their answer has a 955. We have a 956. Rounded to the nearest whole number is the same answer. The tolerance is 0.1. So off by more than 0.1. Okay, I'll look into that. All right, guys, that's the longer than I anticipated. Sharing out.